Section 6 is strictly on isosceles and equilateral triangles. And we're just going to use some information that we know about those triangles, and we're going to use them to solve for side measures or angle measures, depending on what the triangle is. So first things first, we've already talked about isosceles triangle has two legs or two sides that are congruent. Right? Two of the sides out of the three are congruent. And we have a couple theorems for our isosceles triangle. Well, if two sides of a triangle are congruent, or if I have an isosceles triangle, then the opposite angles to those sides are congruent. So if I have these two sides congruent, that means their opposite angles, so the angles opposite, would be congruent to each other. So I know those two angles would be congruent. And we call these the base angles. So I know that these base angles are congruent. The sides opposite the sides that are congruent. And they should look congruent, so that should make sense. And the same of the converse, right? If I flip-flop it. So now if I have two angles of a triangle that are congruent, I can automatically say that the sides opposite are congruent to each other. Okay, so vice versa. All right? And we call that the isosceles triangle theorem, or the converse if we start with the angles. With equilateral triangles, we have a couple of corollaries, and it's kind of based off our isosceles triangle theorems. So first one says a triangle is equilateral if and only if it is equiangular. So basically, it also has to be equiangular before it to be equilateral. And if I had an equilateral triangle, I would know that each angle is what? 60 degrees, which is my other corollary. So if I have an equilateral triangle, that means it's also equiangular, which means that every angle is 60 degrees. There we go. So equilateral triangles always have 60-degree angles. Let's try a couple examples here. So it says find measure SRT. So I'm trying to find measure of SRT. So I'm looking at this angle right here. Well, if I notice, I have sides that are congruent. Well, it's an isosceles triangle. That means the base angles are the sides. The angles opposite of those sides are also congruent. So if I look, these are the two angles that are opposite those sides, which means these two are congruent. Well, and I know that triangles add up to 180 degrees. And if I subtract 40 from 180, I'm left with 140. And if these two angle measures, angle S and angle R, are the same, I could just divide my 40 by 2 to find out which each one is. So 70 degrees. So I could say measure of angle SRT equals 70 degrees. There you go. So using your isosceles property, your isosceles theorem there. How about this one? Find the value of the variable. So we have an x and a y. Well, immediately I see that I have sides congruent by those marks, so I can set those two expressions equal. I can say 6y plus 3 equals 8y minus 5, because I know those sides are congruent. So I'm going to start with that. I'm going to solve for y right away. Well, I'll get my y to one side. I'm going to subtract the 6y to keep my y positive. That's gone. So 2y minus 5, get my y by itself. It's going to add 5 to both sides. And we end up with y equals 4, it looks like. So there's part of it. Now I got to solve for x. Well, what do I know about x so far? Let's look at these angles. Well, this is an isosceles triangle, so the sides opposite, right, would be congruent. So I know those two are congruent, so I know that this guy right here is also 4x minus 8, right, because those two are the same. Well, then if I look, this one, angle E, is also 4x minus 8. So all three angles are the same. Is this an equilateral triangle, it looks like? Well, one common mistake is I'll see people try to do this. They'll be like, well, since those angles are the same, I can just set them equal. Well, that doesn't help me, because my x's are going to cancel each other when I subtract 4x on both sides. So don't do that. Don't set them equal. We don't want to do that. So what can we do? Well, what else do we know about equilateral triangles? I know that each angle adds up to 60 degrees, right? Isn't each angle 60 degrees? I know that this is 60, I know that this is 60, I know that this is 60, since they're all the same. Or I could have added all three together. I could have said, well, I have three of those angles. So 3 times 4x minus 8. And set that equal to 180 because triangles add up to 180. Well, I think I'm going to deal with the one up top. This seems a little bit easier to solve for me. So I'm going to go ahead and add 8 to both sides. And I'm left with 4x equals 68 and divide by 4 to give us x equals 17. So there's my two answers. Okay, and I would have got the same thing if I would have solved this green equation here as well, but decided to deal with that one up top instead. All right, so you just got to plug in what you know and figure out what way to set up an equation to solve. That's really all there is to it. So basically just look closely, use the information that you know to set up your equations, and go ahead and solve them.